a student, question number 2. A student used a transparent tube to measure a volume of liquid as shown. Opening the tap allows liquid to flow out of the tube at a controlled rate. When the tap is open, the volume of liquid inside the tube decreases with the time according to the relation V is equal to V0 e to the power of minus Bt, where V0 is the initial volume of the liquid in the tube and B is a constant. Explain why a graph of len V against T should be used to test this relationship. Anyway, the equation for the volume and time is V is equal to V0 e to the power of minus Bt. Now take log on both sides or len on both sides. So len V is equal to len V0 minus B into T len E. So the equation now becomes len V is equal to len V0 minus B into T. So this is in the form of y is equal to mx plus c. So if you're comparing the coefficient of t, that is the gradient. So the gradient is equal to minus p. And this is a reason why we are drawing or we are using len v against t for checking or testing this relationship. Clear? Now, B question. A student investigates the relationship between V and T. Describe how the student could obtain an accurate set of values for V and T to test this relationship. So we need to write all the points associated with this. A student investigates the relationship between V and T. Describe how the student could obtain an accurate set of values for V and T to test this relationship. So we can say that open the tab and start recording time. Record volume at successive time intervals. How will you read this? Read to the bottom of the liquid meniscus. That is very important. Otherwise, error may happen. And now, one more thing we should be very careful. Record many measurements of P and T. So valid points for carries 4 marks. Clear? Explain a source of uncertainty in this. What uncertainty? Explain a source of uncertainty in this investigation. So main problem is it is very difficult to measure volume and time simultaneously, and which affects the random error. It may be very difficult to measure volume and time simultaneously, which will affect random error. Clear? Or you can say air may be trapped in the tap, which will affect the random error. That is also giving you 2 marks, the valid points. So these are some of the uncertainties in this investigation. So that's about question number